So we're doing question 4. We're still doing loci. In this particular one, the last one we found was a circle. It just looked a bit weird. Now, Baden, when you did it, was that the one you completed the square so it looked much nicer? Yeah. So we'll look at that sort of stuff later. All right, this one, number 4, we're going to find the equation of the locus of the point P that is equidistant from fixed point A, which is at 1 minus 2, and fixed line with equation y equals 5. So it's not 2 points. Which one? Equidistant? Yeah, equal distance. So I could have said equidistant. Some people will say equidistant. Some people will say equidistant. I like to mix it up a bit so you think I'm strange. It help? Huh? Yeah, well, true that. All right, so what we're going to do is, first one, we're going to put those points on there that we've been given. So point A is at 1 minus 2, and I'm going to see if I can get it right this time. There we go. So that's A, 1 minus 2. And the other one is at y equals 5. Now, the other ones we've done, the previous ones we've done, have 2 points. This one has a point and a line. So that's our 2 conditions, if you will. And we're looking for the point P that is equidistant from the 2. Now, you could obviously go, that's 7, correct? The distance between the line and that point is 7, vertically. So I could go up 1, 2, 3.5 and do it there, and I would be equidistant. Does that make sense? Okay. I could also just go about there or about there, and you'll see that it's actually going to be a curve, but we'll worry about that later. So I'm just arbitrarily picking a point, and I will use that one because I know that it's definitely on it because it's 3.5 up, and I will call that point P. I don't know why I put the bracket there. It's got to do with stupidity, really. Okay. And then that is equal to that, and I'll just actually mark it so we recognize the fact that it is equal. Cool? Thank you. Everyone happy with that? Okay. So, what do we want to do? Baden, you've done this one, haven't you? What did you do? What was the first step you took? Because it's interesting, because I think the steps that I assume that you would make, you guys aren't necessarily seeing as a logical first step. And that's normally the problem. Once you've done the first step, the others follow. So what did you do first? Yeah, okay, so you wanted to use the distance formula? Okay. So all of a sudden you've got this PB thing going on. At the moment we don't have a B on there, do we? Okay, yeah. So what you're doing is basically you're defining a point. Okay. Does that make sense to you guys? All the other ones we've done, all the previous ones, we've had 2 points, right? And then we say, well, this one equals this one, or this one is double this one, that sort of thing. We've done that in the previous ones. At the moment we don't have 2 points. We've only got 1 point. You agree with that? Okay. So what we're going to do is, just to make our lives easier, we're actually going to put a point on that line, on the y equals 5 line. Does that make sense? Because that way we've got a PA and we'll have a PB. So I'm going to put my point B there. Now my y value is 5. This is going to be where it's interesting. Nick, what do you reckon the x value is on that line? Because remember, my point is going to be moving. So at the moment, you've given me a y value. Oh, you gave me the positive version. Yeah, I want an x value. Sorry, what did you say? What did you say? Okay, it is 1 in this particular spot, but what happens if this point moves? That point's going to move, isn't it? It's going to vary. What would I call it if it's going to vary on that line? Well, it's going to vary that way or that way. So what might I call it? Because where did you get the 1 from? Why did you get 1? So because of the point A, and what value is 1 in the point A? Which one of the two? It's going to be point X. We don't know what X is at the moment because it depends. It's always going to be 5 because that's the condition we were given. That makes sense? But as this point moves on its locus, that is going to move because it's got this has to move to stay equidistant from there to there. Okay, so point B is going to move so that the PA and PB stay equidistant. Does that make sense? So X is going to change. X is variable. But the Y value of 5 is going to stay the same because that's what they gave us in the question. Cool? If you actually drew that and then dragged your point P, you would find that B would move across to the left as you dragged P left, and then B would move across to the right as you dragged P right. Does that make sense? Okay? And then if you had, like if you were using GeoGebra and you put in there PA must be equal to PB, then when you dragged P across, you'd find that that point would describe a particular shape. And that is the locus. And that's what we're trying to find the equation of. Does that make sense? If you drew it in GeoGebra, you can actually draw this in GeoGebra, put those conditions in, put a point there, put the directrix, or not directrix, put the line there, y equals 5, and put the point P and force it to be equidistant. Then you can click and drag it around the page. And you will see what it'll do. Because GeoGebra will force PA to be equal to PB the whole time. And B will move across, left and right, and P will describe a shape. When I say describe, it means draw. It describes it. Okay, so that's what we're trying to do. So, we now have that. So we've got PA and we've got PB, okay? So what I'm going to do is, by doing that, let B... I don't know. I'm going to get rid of the equals because it looks stupid. So all I'm doing there is I'm saying I'm making a point B and it's at XY. X5. Happy with that? So now I've just written down what I did graphically. Sorry, didn't mean to cough. So that's B's coordinates. B has the coordinates X5. Cool? Now I can go back to the way I've done all the others. What did I do? I'm going to use the distance formula. So, we know that PA equals PB because that's in the question, correct? But if we want to use the distance formula, we don't have PA. What do we got? Distance formula. It starts with D squared. So we don't have PA, we have PA squared. Because we've got PA is the distance between P and A, PB is the distance between P and B. So we have PA squared equals PB squared. And we're happy with that. That's still the same thing. We've just squared both sides. So now I have to write down PA squared. What's my distance formula again? Okay, so yeah, your x2 minus x1 plus y2 minus y1. Okay, so I've used A's coordinates and P's coordinates because it's PA. And then I know that that is equal to what? That one? Yes, but it's a minus 2. Minus minus 2. So I'm jumping steps again. Me bad. Before you do that bit, are you going to you're going to expand that one? I was going to put PB squared next to it. Do you want to expand that one first, or you want to do PB? Oh, okay, cool. Go. Yeah. Sorry? I went a lot quiet. Yeah. Well, you guys do that. You start off Because you're confident. And then as you talk, you think, hang on, am I sounding stupid? And I'm going to get quiet. And you're right, you do sound stupid when you get quiet. But I think you're working well. You're doing awesome. Okay. So we're happy. We've got PA squared, we've got PB squared. Everyone happy with that? All right, let's do it. Expand away. We've got perfect squares. Hopefully everyone remembers perfect squares. Square the first, square the last, double the product. Okay. Check yourself, see if you've got the same as me. In other words, make sure I didn't make a mistake. Baden. Stop mocking me. 11 minutes. Sorry to all you people in internet land. For your entertainment, we'll play some music. There's Simpsons music? I don't want to. I don't know the theme song. No, if I was kidding, I would have said, why did the chicken cross the road? To get to the other side. Weirdos. Why'd the computer cross the road? Took the chicken's job. Why'd the dinosaur cross the road? Chickens weren't invented. Alright, so, enough of that. What do we got to do now? We've got that. You're right, they do get soft. What? Collect like terms. Awesome. So we've got an x squared there. Got a minus 2x plus 1. So there's nothing to collect on there. So we're going to have to drag them all from the right over to the left, yeah? Easy as? So I've got x squared. That's fine. Minus 2x is fine. Then I could have collected the 1 and the 4, but I'll do that in the end. I've got a y squared there and a y squared there. They're going to cancel each other out. I've got a plus 4y and a minus 10y, so that becomes plus 14y. Then I've got a plus 1 and a plus 4 is plus 5. Minus 25 is minus 20 equals 0. Everyone happy with that so far? I say so far because I want to rearrange it a little bit more. That is the correct answer. We don't have to go any further, but I'm wondering if you guys can recognise what shape that is without me manipulating it. It is not a y squared. Perfect. It's not a circle. Excellent. It is a parabola. Sorry? It's not a semicircle. A semicircle, yeah, it has a square root. It's got the x squared and the y squared, but it has a square root. This one is a parabola because y is only, it's power of 1, but the highest power of x is 2. So therefore it is a quadratic, it's a parabola. Cool? Now, if you actually, like I said, if you were on, yeah, it does say that down there. I was going to point it out. You guys are awesome at not reading stuff ahead. If you did that on GeoGebra, you would find that when you dragged it round, it wanted to do that sort of thing. It would make a parabolic shape. Okay, you'd go like this and it'd go way, way. Okay, because it's trying to stay equidistant. And it would never come back around. It would keep going out and out and out and out and out and out and out, but it would just go less and less out each time. Cool? Parabola! Oh, look at that. Minute and 13 seconds ago.